today's math lesson, we're going to be, and that lamp is driving me bonkers. I don't. It's on the same mode that it was. The light is just going out. Okay, what we're doing in today's lesson is we're going to be comparing and ordering fractions and mixed numbers, okay? So comparing means I'm going to look at them and find what? What might I look for when I'm comparing fractions, Hayden? Okay, maybe what I need to divide or multiply by. But usually when I compare fractions, I'm looking for which one is the biggest or the smallest, okay? And if I'm ordering them, what does that mean? What does it mean to order them? What does it mean to order fractions or numbers? If I'm going to order them, am I calling on the phone and saying I need 7 of these? No. No. Okay, what does it mean to order them, Keely? From least to greatest or greatest to least, I'm putting them in order of their value. Okay, but the tricky part is sometimes it might give me mixed numbers. Sometimes it might give me, it might give me 5/6 and 3/4. Okay, and it says we have to compare them. So I want to know which fraction is greater than, less than, or equal to? Okay? How many of us off the top of our head know which one is greater than or which one is less than? You do? How? Don't tell me because this is 5/6, it's more. Greater than or less than? Explain to me how I can find which one is larger. What do you think, Elliot? Add them? What did you do on the butterfly effect? You could definitely draw a picture. Okay? But if we want to go back and do the butterfly effect where we're comparing them, I thought you multiplied them, Elliot. Okay? 5 times 4 is? 6 times 3 is?
18.
20 is more than 18, so 5/6 is larger than 3/4. How can I check this math? How can I trust that butterfly effect? How do I know I don't add them like Elliot says? I could draw a picture. Can you tell by your picture? I could create common denominators. Okay, so let's look at 5/6 and let's look at 3/4. How do I create common denominators? What do I have to do? This is a skill you covered last year, folks. How do I create common denominators? Chelsea, what do you think? There's one before that. I would list the factors. We talked about factors once already this year, folks. Okay? 6 times 1 is? 6 times 2 is? 6 times 3? 6 times 4? All I'm doing is factors. Again, multiplication tables. Okay? 4. 4 times 1 is? 4 times 2 is? 4 times 3 is? I can stop right there because I have a common factor. Okay? So what I can do, I like to write my numbers up and down. I like to write them vertical. Okay? I'm creating equivalent fractions. That's all I'm doing. I'm just creating equivalent fractions. Okay? And I'm going to use this denominator, this common factor that I found, as my new denominator. These should look familiar. You did some like this in your homework last week. Okay? How did I get from 6 to 12? I multiplied by 2, right? 5 times 2 is? How do I get from 4 to 12? Landon? Multiply by 3, right? What am I going to do to the top? To the top? 3 times 3 is? 9. If I have the same number of pieces, is 10 more or is 9 more? So 5/6 is larger. And when I compare that, my voice is going to go out, I'm sorry. When I compare that to my butterfly effect, we got the same thing. 5/6 is larger. Okay? Here's one for you to try on your own. Try. 2/3 and 4/7. Tell me which one's bigger. Okay, you're doing 2/3 and 4/7. Folks, your focus should be on your board. Who did butterfly method? Okay, I want to know greater than, less than, or equal to. Okay, I can quickly compare two fractions using the butterfly method. The butterfly method is where we take the numerator of the left and the denominator of the right and circle them. Then we take the denominator of the left and the numerator of the right. You can draw the pretty little antennas if you want to, whatever you want to do. Okay? And I have to multiply those two sets of numbers. So 2 times 7 is? 14. 3 times 4 is? Okay, is 14 larger or is 12 larger? So 2/3 is greater than 4/7. Would you agree? The only time that you get to a 2/3 is more than 4/7. Because 14 is bigger than 12.
You can do it the other way. You can take 2/3 and 4/7
And find common denominator.
common denominator, which would be
7 times 3 is?
21.
All right. Let's look at 2/3 and 4/7, the old-fashioned way that we've been taught, where we have to create common denominators. Okay, folks? Shh. Listen, because I understand DI has to leave, but we will not leave until we are complete. Oh, okay. I can create equivalent fractions by I can either list the factors, 3 and 7. 3 times 1 is? 3 times 2? 3 times 3? 3 times 4? 3 times 5? 3 times 6? 3 times 7? 7 times 1? 7 times 2? 7 times 3? I have a common factor of 21. Okay, one way that you can always create a common factor too is to multiply your two denominators. 3 times 7 is? It won't always give you the smallest denominator, but it will always give you a common denominator. Okay? So, how did I get from 3 to 21? Dave, if you are lost, I would be looking up here. How did I get from 3 to 21? So if I multiplied the bottom times 7, Leslie, what do I have to do to the top? If I multiply the bottom times 7, what do I have to do to the top? Multiply by 7. 2 times 7 is? If I multiply 7 times what to get 21? Chloe? If I multiply the bottom times 3, what do I have to do to the top? Caleb? 3 times 4 is? Those numbers look familiar, don't they? Would you rather have 14 slices of pizza or 12 slices of pizza? If you're really hungry, you probably want 14. 2/3 is greater than 4/7. Yep. Let's very quickly look at that. When we did our butterfly effect and we took 2 times 7 and got 14, and we took 3 times 4 and got 12, look, I got the same numbers as I did when I multiplied my common denominators. Okay? This is probably a pretty easy one. Most of us can probably, if we have any fraction awareness at all, could probably guess this one and get it right. But I want to see your work on your board. Prove it to me. Okay? You could do one of two ways, folks. I could take 3, 4, and 10 and find common fractions or find common denominators for all 3 fractions at the same time. I could choose to just do 2 fractions at once, find which one is bigger, and then figure out where the other one falls in place by then doing that 3rd fraction. Okay? I could just do the butterfly effect a couple times to figure out which one is larger. Okay? So if I choose just to do the butterfly effect, here's what my work might look like. 2/3 and 1/4. Okay, I have to circle my diagonals. 2 times 4 is 8. 3 times 1 is 3. 8 is larger than 3, so I know 2/3 is larger than 1/4. Right? Okay? 9/10. I'm going to start by taking 9/10 and 1/4. So I have 9/10 and 1/4, and I want to know which one's larger. I'm going to do my butterfly effect with these two numbers. 9 times 4 is 36. 10 times 1 is 10. So I know that 9/10 is larger than 1/4. Now I have to figure out if it's larger than 2/3. So now I'm going to take